So if you look at the top of the page, we're going to do more with dilations today. Question number 1, we're going to take and dilate a line. Okay, so I want you to think to yourself, dilations, our figures usually get larger or smaller. Does a line really get larger or smaller? And then we're also going to construct a triangle that's dilated by given a scale factor, a specific scale factor in number 2. But to start, I just wanted to review again the properties that are preserved with a dilation and just highlight within this figure. So if you take a look, the given figure, let's say the given figure is the blue. Okay, so let's call this ABC. Well, there is an A already there. So let's call this B. And there's A prime, so this is going to be B prime. And then we call this C. This is going to be C prime. I want you to take a minute, and what do you notice about the center of dilation, which is the origin? Think about this to yourself. And then what do you notice about the center of dilation? B prime and B, for example. So when you dilate a figure, so in this case, in changing all the points to the correct notation with the image in the original figure. Yes, if you look at the segment again from the center of dilation through the point to its image, B is the midpoint. Okay, so I just want to make note that B is the midpoint of B prime. And I'm going to use COD for the center of dilation, just to abbreviate. Okay, so then also too, A is the midpoint of A prime in the center of dilation, as well as C. So what are all the properties? We just talked about that collinearity is preserved. What else is preserved from the note sheet from last class? What else is the same? Angle measure, good. What other properties are preserved? Is distance preserved? Distance or length? No. So property not preserved is distance or length. What about, I'll give you the words, you just tell me yes or no. What about betweenness? Okay, remember, betweenness just meant that, I'll use the orange, if there was a point that was between, so I'll call it M prime. If we have a point that was on the original figure between A and C, the image would also be between A and C. They're still collinear. So betweenness, parallelism, anything else? There was one other, orientation. Does orientation remain the same?
Yes.
Yes. So here, from A to B to C prime, the manner in which we label our vertices is both within a counterclockwise direction. So the only property that's not preserved is distance or length. So if we go to dilate a line, by definition, a line extends infinitely forever in both directions. Okay, so first it wants us to start by graphing y equals negative 1/3 x plus 2. So my y-intercept, again, we've got a y-intercept of 2. It's in standard form, y equals mx plus b. So you should be able to quickly identify your slope and intercept. So starting at 2, down 1 over 1, 2, 3, up 1, 1, 2, 3. So what am I going to do to dilate the line? So since in a dilation, again, parallelism is preserved, we know that this new line is going to have the same slope. And to make it easy, we're just going to dilate the y-intercept. So my slope's going to be negative 1/3. When I dilate to the point 0, 2, again, the y-intercept is 2, so coordinate 0, 2. When I multiply both of these by 2, so 0 times 2, 2 times 2, we now have a y-intercept of 0, 4. So move the line up 2 units. Again, it's going to have the same slope, so down 1 over 1, 2, 3, up 1, left 1, 2, 3. The line's going to be parallel. So number 2, using our compass and straight edge, we're going to construct a scale drawing of triangle DEF with a scale factor of 2. Now note that this does not say to draw it separate. So off to the side, draw it. So what we're going to do is we're going to use the original figure and just make it twice as large. Okay? So we'll have overlapping figures. If it said to draw, just to talk you through it, if it said to draw the triangle off to the side, not only do you have to construct congruent segments, but you also have to construct what? Or not congruent segments, but you're going to have to, you'll see what I mean. So you'll have to double, remember from the beginning of the year, you'll have to double your side lengths, but you'll also have to, if you have to draw it separately, you'll also have to copy the angle over. And we don't want to have to do that. So to do this construction, we extend the given side. So with your straight edge, take your tool and extend. I'm just going to, you can pick any two sides. I'm going to extend here and here. And remember, from the beginning of the year, to copy a segment, you take your compass, put it on your endpoint. You have to show that you measured. So I'm going to put my compass point or the pencil on D and make the arc to show that I measured. Thought I was in green. So that's the exact length. I just showed that I measured that length. Now to make it twice as long, you take your compass point, put it up on D, and make the arc again. So this, if we did have to label, this would be D prime. It doesn't say to label, so you don't have to. I'm going to do the same with side EF. I'm going to take and measure it. And I'm going to make it twice as long. And this is going to be F prime. Take your ruler and connect D prime and F prime. So that would make down below, not only is this point E in my picture, it's also going to be E prime. Those are overlapping triangles. Now just to review, because this is twice as long, D and E are both what? Those points. So point D and point E are midpoints, correct? And we just recently had a Regents prep question where you had to find the length of either DF or D prime F prime. Because these are midpoints, DF is a mid segment. And that's the only time it's a mid-segment. And if D prime F prime was 8, what's the length of DF? 4. That's the only time it's half, is when those 2 points are midpoints. Okay? So let's take a look at the next page. So translation. A translation, think about the game checkers. You're sliding the checkers across the board. Okay, so a translation is a slide. If you were just reading the paragraph, it's where all the points in a figure are moved the same distance in the same direction. Okay, a translation can also again be referred to as a slide or a shift. And then we have a vector that's used to demonstrate the distance or magnitude and direction of your translation. Okay? Because both distance and direction are fixed, both the original figure and its image are going to be congruent. So if they are congruent, is angle measure preserved? Between this, distance, is there anything I'm not checking for a translation? No, they're all checked. In the coordinate plane, now a translation AB, okay, so you take and you add the number that's in the spot of the A to the X, and then you take this number and add it to the Y. So in the first one, all we have to do is simply draw the vector that demonstrates the translation. So take any point in its image. So let's look at, pick a point. What letter? C. If I take a look at C, again, you're going to want to utilize your ruler, but I want to take and draw a straight line, not connecting, because I'm going to turn that line segment into a vector, so I need to put what at the end? What's that? The arrow. So that's the vector noting that shift. And we're going to do this again in the graphing question. Number 4, determine the coordinates of the image of the point 5, -3 under that translation. So again, all you do is take, since this is in the spot of the X and that's in the spot of the Y coordinate, I'm going to subtract 2 to the X. I'm going to subtract 1 to the Y, and my new coordinate is going to be 3, -4. In number 5, we have to determine the translation that maps the point. So some of you can see this, okay? But if I want to know how did I go from here to here, again, what did I add to -5 to get to 7? You can solve it algebraically if you need to. So if you add the 5 over, X is 12. How did you go from 5 to a 1? Again, if you can't see it, what did you add to it to get 1? When you subtract, you're adding a -4, or just simply subtracting. Okay? So the translation, T, is 12, -4. Number 6. A translation maps the point -2, -5 to the point -4, -4. What is the image of 1, 4 under the same translation? So we have to figure out that translation first. So how do I move? Can anyone raise your hand and tell me? From -2, -5 to -4, -4. What's that given translation? Can anyone tell me how we're moving? Damien?
-2 plus 1.
So translation -2, 1. -2 minus 2 is -4. -5 plus 1 is 4. So now I'm going to take the point 1, 4 and subtract 2 and add 1, and we get what for our new coordinates? Final answer is -1, 5. On the back of number 7, it says the image. So you have to pay close attention to the wording. That's the result you get. The image under the translation, 3 negative 4 is negative 1, 5. So you want to say to yourself, what did I start with? Add 3, end up with negative 1. What did we start with? Subtract 4 and get 5. You're finding the original point given the image. How would you, instead of adding, go backwards? You could also subtract. So when I subtract 3 here in solving the equations that I set up, x is negative 4. Add 4, y is 9. So it's the point negative 4, 9. Last question, number 8. We're going to graph, state the coordinates of the image, as well as draw the vector. So this A, B, C, it doesn't tell me the coordinates, so I'm going to write them first. And this is a translation, negative 3, 5. So this is another way to write your answer if you want to. X minus 3y plus 5 is the translation, negative 3, 5. So the first thing I'm going to do is take a minute, write down what are all the coordinates of the shape, in this case the triangle that they give you. And then I'll show you what I do. Okay? So what I first do is I take a look at one of the numbers in the translation. So the negative 3. So I'm going to take all my x values and subtract negative 3 to all of those. And then I'll go to my y values and I'll add 5. So just say it out loud. Negative 1 minus 3. What's that? Negative 4. 0 minus 3. Negative 3. Good. And then 3 minus 3. 0. Now I'm going to go and add 5 to all of the y coordinates. So negative 2 plus 5 is 3. Negative 4 plus 5, 1. Negative 1 plus 5, 4. So here's part of part A. There's the stating of the coordinates. Now I'm going to graph those. Negative 4, 3. Negative 3, 1. 0, 4. And I'm just going to sketch it by hand. You could double check each of your points. Do I move from A to A prime? Do I go left? 1, 2, 3, up. 1, 2, 3, 4, 5. I do. So you could have, rather than figuring out all the points ahead of time, take them, move them left 3, up 5, and then go back and write the following points after you've graphed. Okay? Now to finish, we just have to draw the vector that defines the translation. So you pick any point in its image. So what's the letter you want to draw the vector for? C again. So from C to C prime, there's the vector. Now what I'm going to show you quickly, which is next year in Algebra 2, or maybe Cody could speak up, I'm going to show you how to find the length of that vector. Okay? Does anyone have an idea other than Cody? Again, you're going to do this next year in Algebra 2 trig, but it's so easy. It'll give you a leg up on one of the topics you're going to learn. How would I find? We want to use distance formula? Yeah. You can, but in the coordinate plane, instead of doing distance, it's really easy to do Pythagorean theorem, right? So what's this distance here? You were shifting left 3, so this is 3 units. How many units is this? 5. So let's call this C. So the magnitude of the vector, again, that represents distance. That's our C. So C squared is equal to 3 squared plus 5 squared. The sum of 9 and 25 is 34. Taking the square root to undo the square, we end up with C equal to radical 34, negative radical 34.
Always reject the negative.
Good. Always reject the negative when you're talking about distance. So the magnitude is the square root, or length of that vector is the square root of 34 units. Okay?